Okay, okay. So, I watched this. Watch this. Also, fantastic. And I've been just kind of researching the Rockies to get a better grip on the details so I can basically be more able to apply my interpretation to the totality of evidence with a sufficient accuracy where it actually begins to like come together. Hopefully that's the objective. Oh, okay, so I'm finding stuff in the Rockies. The Rockies are really interesting because they seem to have formed across a long period of time. Okay, so we're gonna start with notes. I just took notes. It's it almost helped it. It's like I'm in class. I really feel like I'm in class. I'm like sitting here taking notes, like pause. Like it's how did I do? I was literally like, how did I do this as a child? Like live action. I guess the information rate was not as much as like a lecture, like really technical lecture, but like what about college? Anyway, like it's nice to be able to pause and like really gather the information, replay it, and be like, what just happened? Just like, why aren't we like targeting this kind of way? Just because we don't like trust people to learn. Maybe it's because our education system isn't interesting enough, and it needs to be more accurate because reality is way cooler. Pardon me. Okay, let's go on. Let's go on or begin. So, southern Montana to New Mexico. I'll just mute me. I guess my phone was open and watching clips. Okay. I saw a real interesting clip on Facebook. They took a huge snowball. Maybe we can even find it. Let's find it. Maybe it's on YouTube. Huge snowball off bridge. Yeah. I don't think this is even it. Oh my god, but the just the way. It's got like flat sides. No, check out the shape. That one's a hexagon. It ripples out in a circle, but then it takes like a square. Oh my god, there's so much cool stuff going on. It's got like a hexagonal sides at the center there. Satisfying. Oh my god. It's like a miniature like the awesome experiment for science. Oh, it's so cool. And then it freezes here. Like, okay, that's all. Like, it's as if like a impact occurred that then freezes. Like and then the water flows in beneath and fills the gaps like a sill or dike. Pardon me as I use geological terms that I think I'm appropriately using. Let's see, maybe this one. Let's check out what I haven't seen this one. This I'm a little afraid because there's small children on the edge of this bridge. Oh, not enough water. Okay. That's just for the view. Just for the view. Oh my god. Where is this? Washington State? Oh, what a river. It's a glacial river, I guess. Wow. The color of that river is something. I've seen a lake like that. I've never seen a river like that. It looks fun as hell. Not to encourage anything. Start smacking the, like, who knows what kind of, like, ripples. Next thing you know, there's an avalanche 3 miles away. Oh, that couldn't be related, unrelated. Speaking of that kind of thing, let's check this out a little bit more. I wish I could, like, is there a way to max screen these things? I don't think so. Wow. I mean, I think they posted the other one. Maybe, let's see if it's, this is top awesome. Okay. I don't know if they have the other one. Oh, I saw this too. This is interesting. So someone was like, the strongest man alive. Okay, anyway. Let's give it to the Rockies. Okay. It's time to get serious. Okay. Southern Montana. So I brought this up. Southern Montana. This is the Laramide orogeny. The Laramide orogeny begins in southern Montana and goes to New Mexico. So I think it's this region. Maybe that's. I know it's kind of ridiculous for geologists to listen to me when I say things of that nature. Just, I'm coming from a different angle. It is what it is. What I'm finding is really, it's fitting my interpretation pretty well. It's exciting. Okay, so I guess it's generally from here, or maybe this way. The mountains Front Range in Colorado, Sangre de Cristo in New Mexico, and Bighorns in Washington or Wyoming. So Bighorn is here. So that one is the Laramide orogeny. So this was all considered to be in the region of 70 million. We'll go into more detail. She says peaked in this video. This is information from this video. Peaked about 60 million years. 60 million, which is pretty in the time frame of the supernova event in the Pacific of this system that is novaing of its scale, a supernova in the fractal way where it is seen as a star, and it's large enough of a system that it has like large scale effects when it supernovas on the surface of the planet, basically caused by the Earth's expansion process, by currents flowing under the crust and colliding with one another and pressure building up and leading to what appears to be, from this video I'm gathering, maybe I can find the image. It has Australia. I think she showed it recently. Kendra Murray, Idaho State University. That's who gave this one. Awesome. It's good research. It's about the temperature that the rocks have experienced and like the ways to determine all sorts of information based on the just the helium content in certain rocks. It's something of that nature. I'm trying to find a specific picture. There it is. There it is. There it is. Okay. So interestingly, we have what appears. I'm not sure what's going on here. If this is like where Papua New Guinea is up here. So I've been running into this concept like with the expanding Earth, where the expanding Earth puts Papua New Guinea up here, and I've been putting Papua New Guinea physically exactly here to here, where there are actual bonds. I know, making things up. No, just recognizing that which is and applying the name, the obvious name to it. There are bonds that are there that continue Papua New Guinea, and then double bond over here. Single bond, double bond. Single bond, double, 1, 2, like two broken bonds. I don't know if it's truly like a single double bond. I never had that thought that this was a double bond and this was a single bond, but it does kind of make sense. Whereas over here is another single bond, and then this whole region was down here. I'm not sure what to make of it in that kind of sense. Maybe it was, it's almost like a hydrogen bond to that one. I don't know. Like a hydrogen. That doesn't make sense. Just some fun thoughts, part of me, as I consider the chemistry of the Earth, which is present because that's what's going on. These bonds. I don't. It's not just like a word that happens to sort of describe like a connection. Like it's actually a chemical bond that required sufficient energy to break the bond, because essentially a current flowed around two particles that had a current connecting them. Maybe we can look at this. This is probably a good example. In the currents of the ocean, or the currents, there we go. It's like, did I choose the wrong thing? Surely we'll find like a double system like this that's like two systems, although that one's spiraling in pretty sharply. But two systems that overall have a current that wraps around them, but also a current that individually is present only at them, although this one looks like it's really spiraling out so that it doesn't have like a stable orbit. Like here it's almost like that's what's going on, is there's a stable orbit where stuff in here just it doesn't move radially in or out relative to the central object very much, whereas over here it's like one time around the circle and it's back over here, and then it's over here, and then it's out here. So it's not really orbiting. This one more so. So anyway, that's in a gist though. That's what's happening. Like there's physical bonds that are like this, that are essentially cause differentiation of the material, so that there's actual different materials in the rock that are like the particles, because that's what they are. Like shallograms, but like this. A particle, a large particle. Here's particles. with currents around them. Maybe these have like even examples of multiple current, like multiple particles that have basically a current around them, but then also a larger current around multiple. Although this one doesn't seem to have exactly that. Like this one and then this section are combined overall. These are probably from geology tweets on Twitter. Most of them. Okay. Here we go. Like these. Um, this is pretty. Like here are like two particles and their bond is breaking. Over here, maybe it's here and here, and this is like the bond breaking. Not sure how it works across all scales. I haven't really thought about this one. This is kind of. This one shows shallogram features pretty strongly down here. This is in the Damodar-Kund region where shallograms originate and are only found. And the wall, which is thought to be fossils, this is believed to be a fossil. And there is a wall of the mountains that looks like this because it's not a fossil. It's caused by current flows. Okay. So, like, maybe this, that looks like a shallogram in there. I wonder if, like, there's more. I don't know. I don't know what that is exactly. I think that was a Shiva ling. I'm just not sure. Sometimes I wonder if they're literally formed in currents. Okay. Let's see. The front range, the laramide orogeny is structurally much different from the northern Rockies, which are Canada and parts of Idaho and western Wyoming, so this region pretty much, and western Montana. I'm not sure how far up it goes. It must go up here, but I'm not sure. So I guess the Rockies are this stretch here, and then the Laramide. This is the Sevier orogeny, one of the two orogenies, even though based on what I'm finding, Sezier, I think I wrote it. I don't know. I don't think that's that though. One of the two orogenies, but the two seem to be the same orogeny, just with nuance dependent on circumstances. Because essentially we're interpreting the time frame to be actually what we're interpreting the time frame to be, rather than like accounting for that the Earth supernovaed, and so there was a lot of radioactive decay quickly, and it just looks like a lot of time, but like it's good in terms of its precision, but it's not the actual amount of time that's passed. So that makes it a little hard to like envision the like currents that were flowing when the currents are flowing like an inch a million years. They're not flowing or whatever. Not, no, that wasn't close to accurate, but like not fast. But if they're flowing, then like we can envision it, And it's like, oh. And it doesn't even really make sense for them to flow slowly. They really have to flow like flowing to, and then to stop flowing because like the energy is just exhausted and it just lays down where it lies. Okay, so the Northern Rockies have folding and low angle thrust faulting, so it's just really slid atop with folding where it's running into things, ramping over top, sometimes hitting plutons, bouncing back apparently, which is cool. Collision of one or more microcontinents is driving force in Northern Rockies, so pretty much the collision of the material in this region, I guess, is being attributed with it. I'm not sure how down here. I guess collision like across this region leading to this. Okay, sure. Southern Rockies, deeply buried crystalline rocks lifted nearly vertically. So down here, the deeply buried crystalline, I guess, basement rocks, lifted nearly vertically, just brought up along steeply dipping faults, uplifting young sedimentary rocks. So it's almost like whatever the current pushing into the continental crust was overlaying it to a degree, but then it was also like pushing into it. So as it pushed into it, it was able to like release some of the energy atop it, but then it kept like causing resistance from the general thickness. And then that resistance, like I know it must have, I guess it just, that was the boundary of resistance and it caused like a upwelling. I'm not sure what to, I know guys, bear with me as I just go through some things I've been learning and don't have a complete interpretation yet. Okay. Large blocks of ancient basement rocks separated by sediment-filled basins. So it's kind of like little galaxies. It really is like little atoms. There's the large like nucleus hearts, and then the Oort cloud or galactic halo surrounding it of this basin of like sedimentary rocks that filled in the space around them as they moved to a different energy level. Much of sediment eroded, exposing igneous metamorphic cores. Oh, I just wrote that. I don't know what to say of it right now. Some examples: Pikes Peak and Longs Peak in Colorado Front Range. Maybe we could check it out. Pikes Peak, Colorado Front Range. Just make sure we're hitting the right peak. This reminds me of that initially it was thought that I might get to this soon, but yeah, I'm real close. I'll just say it in a second then. Remnants of sedimentary strata present as angled segments called hogbacks, which I just watched a scenic route video on YouTube over the hogback. Oddly, earlier today with my family. by really just watching scenic videos and then going places. Flanking crystal cores of mountains. So the hogbacks are flanking these angled sedimentary strata remnants. Remnants of sedimentary strata that are present as angled segments called hogbacks are flanking the crystal cores of mountains. So it's almost like it broke the core came up, it broke the ceiling into fragments that then behaved as some sort of energetic, like, component of the system in the same, like, atom kind of way. Maybe as a neutron to a proton kind of thing. Or like maybe the plutons, I think, uh, the large blocks of ancient basement rocks, maybe those are like places where current flowed in a sense that basically behaves as a proton, whereas up above the sedimentary rock, although that maybe the sediment is more like a proton, literally. That maybe because it's more subtle too. Where the so like the hog, I know it's ridiculous. So like the hogback is like a proton maybe, where the Pluton is like a neutron. I don't know. I'm just like constantly considering that angle, so it comes across very like it doesn't make sense because it's like an angle being considered. It doesn't have to make sense. It's just an angle being considered. That seems to make sense in a more general sense without the final product. I mean, like that's impossible without taking the steps there unless someone's already done it or can tap into it like in ways that I can't. That's all I can do. All that I know I can do, I don't know. All that I allow myself to do, maybe. Okay. It was assumed that the Rockies had a thick crust below, i.e., why there was a mountain chain. But seismic data shows little variance in the thickness of the crust below the Rockies. A 2 kilometer jump in elevation where the Rockies and the Great Plains meet is not caused by a thickened crust. I'm not sure what I wrote there. I think I was just writing part of multiple statements into one sentence that's not really cohesive anymore. Kind of like what might happen with all this information. Fuck. Okay, let's. Oh yes, they said okay. The cool Farallon plate subducts replaced by hot mantle upwelling is essentially a hypothesis, is what this video is saying. One of the hypothesi is that the cool Farallon plate subducts replaced by hot mantle upwelling, which is buoyant subduction hypothesis. But then she went on to say, one geologist put it, we just don't know how the Rockies formed, pretty much. Okay. Which, I mean, if we were willing to be at that point in our agreement, at least, then we can maybe get somewhere. Although it seems like I'm maybe not at that point, but maybe I am not at that point. I don't know. As I just stare at myself. It's so awkward. No one ever listens to me, so I just look at myself. No, or maybe that's what's going on. I'm just looking at myself. You're so beautiful, self. Okay, the Northern Rockies have a 2.6 billion to 530 million gap in the rock record between basement rocks and Cambrian rocks, which is actually going to come into a little more resolution and be a little more like able to see what's going on with that from the information of this one. But still from this one, wait, oh no. I just hit that video in my notes. Okay. Where did this video in my notes then? Okay. Okay, she was saying that this 2.6, 530. Okay, that's where that's. So from here, missing time, and then beyond the great unconformity. That's why this explains it pretty well. So you did a good job of that? Okay. So, this video here explains this 2.6 to 530 thing pretty well, actually. Oh my god. In terms of what, like, going into it. Missing time is common in rock record beyond the great unconformity. Which is another, like, if we were to, like, take each observation and say plate tectonics or expanding Earth, especially expanding Earth with a rapid expansion where the Earth was attacked by a vortex weapon. Say, which one of these does this observation, like, more so give a point to, kind of like a boxing round, like which model does this favor? That there is missing time is common in the rock record. Is it the one that requires billions of years, or the interpretation that the Earth is just not that old? At least, unless it's all a show. I don't know. I'm willing to accept that you all are just messing with me, but I just don't think that's what's happening. It's almost rude to even entertain, like disrespectful to everyone else to even suppose it in my mind and like live as if it's a possibility. It's almost rude to live as if it's a possibility, even though I know no other way. Like, I just simply don't actually know that it's not. But it is rude, because I mean, I know what it's like, the aspects of it. Let's not get into it. Okay. Geochemistry of basements, rocks can. Apparently, I stopped taking notes. I was kind of a little distracted. Okay, let's go back to, if I can find it. It looks like, okay, here we go. It was early. 900 to 600, this supercontinent existed like this, generally speaking. I believe that what's happening here is plate tectonics is just like shifting things around in order to keep the ocean existent through the time, plus adding enough time to make it feasible. Incorporating, of course, the actual interpretation of how much time. However, there's a lot of anomalies. Like, for instance, just the simple one that, like, where is the time? that is a common occurrence for there just to be missing gaps in the record. It basically means it's not gaps in the record, it's gaps in our understanding. More likely. Like, if it's one or the other, we have a lot of information. And so odds are, not to talk about anything in particular, I always feel bad because now I feel like talking, I want to like pick on any Her presentation, her work is excellent. So no, not, it's really about the collective perspective that has been like, agreed upon interpretation because it's basically been forced into being by dominance rather than persuasion. So if there's a world absolutely, utterly dominated by a viewpoint and something materially different explains the observations through persuasion, it just shows that persuasion like can work, first of all. Whenever it works. Whenever it works, it's and it's a better route than force. Like it's the route to peace, really, in my opinion. I don't know. Maybe peace is the route to peace. Not talking blah 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 blah. Persuade? Are you persuaded yet? You're not persuaded. Okay, you need to hear more. You need to hear more. Did you see my 7,000 hours of video content? You're trying to talk to me without seeing my 7,000 hours of video. Sorry, I don't know how much content I have, but like it really is kind of like, what do I even do nowadays? Ever since I mean, this is gonna be 146. Oh, someone disliked that. That's rude. Psh, psh. I did mean to change this to like that. Let's do that. I don't like people's faces on it. Pardon me. On the cover thing. I mean, it's one thing if I'm watching a video. What am I supposed to do? Not watch them? Maybe, I don't know. Not watch them on camera, not reference them. I feel like I've got to reference at least. Anyway, before I get too tangented, 900 to 600. Australia is. I guess I just wrote some notes about it. I wonder where Tasmania is in my recent couple. Maybe that video, this one of these ones. Probably that one. I was watching a video on Tasmania, and they were saying it's more related to Laurentia in North America and Antarctica than Australia, even though it's right there. Is more related to North America than Antarctica than Australia. I don't see it in here. I don't know where it is. Maybe it's over here. This faulting is interesting. If we look at as if it's going this way. Eyeball. Oh my god. Coming in this portion down here is going down this way basically. And then this portion, maybe this begins to form here. But this portion's going up this way, up there. Which I'm pretty sure runs into this current coming this way from the mantle puncture hole, I know. The first current going this way, coming westward from the mantle puncture hole, coming across this way, across here into North America, this way, down this way, and then across here. But this is later. Beforehand, it was actually coming across here where this feature was formed along this boundary with the current flowing up this way. This map really matches this general shape of the way this is. I wonder, like, even like that's a maybe here or here. So maybe like it comes out here and starts to essentially rotate and put a current up this way, and then it physically causes the chunk here to begin to rotate. As this current goes up this way, it fills in back this way and just continues to widen into more like this shape, but initially it comes in more like a smaller shape in this region and just starts to go up this way because maybe that's more straight than I'm realizing even on the smaller Earth before it expanded kind of thing going on that's not really accounted for without the expanding Earth model being actually considered and part of the process. Oh, I just realized this right here has the shape of the Mariana Trench. What is that I'm looking at? That brought a tear to my eye. Holy. Those moments where I'm like, dude. Like, it's pretty well positioned. I wouldn't be surprised if it's because of a current coming across that at some point, it wasn't from here. It's actually this current is actually flowing up this way, up here, up here, up here, around the top through here, and then down through here in this way, and colliding with this current, and basically going between it and causing this current to branch out. So, like, yeah, that's probably caused by that current, I'd say, pretty likely. Yeah. So, Hawaii must have been capable of being up here. Not sure what to make of this region in terms of before the Earth expanded yet. I'm still working through the details. There's a lot of details. Especially when it's like verses in some ways. Instead of like a co-op thing where it's like, everyone's allowed to have their own models. We support at least any model. I mean, we support any model, but like, we need to consider other models. That's critical. We can't just latch on to a model and just be like, that's it. Unless it's like answering questions like without relent. Then it's like maybe that's more accurate than other things. Like it's just like, oh, see that and how like that. Oh my god, it really like that's, dude. So that means that Australia started up here and moved down this way. And you know how it did that? By the ammonite, it rotating on its ammonite nucleus as it repositioned itself and decayed to a new stable equilibrium of a new system in terms of its atom that it is. It decayed to a new atom. Essentially, this whole region decayed to of Southeast Asian islands that were adjacent. The whole region like exploded and decayed, specifically decayed to a smaller like mass, relatively atom system compared to what it was when the currents began to flow into the region. And so maybe that also caused it to rotate so that it basically moved down this way. Papua New Guinea moved down this way as it like bonded. The bond was being shaped and reshaped as the current just turned it, maybe. Oh, so many possibilities. Okay, let's keep going though. Australia's put adjacent. Oh yeah, no, sorry. I was just reading the same thing that I just wrote. My note to self. Front Range origin, Neoproterozoic rift basin. So that's this rift. One of the major things that she points out is that, of many things, is that this rift basin, the Front Range, or this mountain range, the Front Range, is its origin is tied to Neoproterozoic rift basin. So basically, that this rifting was occurring led to a maximum range outward where, like, rifting influenced and caused a, like, fracturing in the region to initiate a rift basin there, which then allowed for motions to flow, currents to flow, I guess. Where maybe plutons rose through the openings. Maybe they were even heated, caused to heat and caused to like force themselves up in part of the process of causing the faulting. I don't know. Unconformities place these rocks at the surface 3 times before laramide. So, I'm not sure. I just wrote these rocks. Let's find it. That one's fine. 3, so essentially, this is a good way to describe it. The closure temperature of a mineral is the temperature that helium becomes trapped in the mineral. So, like, beyond the temperature, helium just is contained, like, within the boundary of the mineral, which is interesting that this, like, polygonal boundary is heat dependent. So, like, if it's hot enough, the helium can diffuse, maybe? Helium diffusion is temperature sensitive. Buried rocks heat up, exhume All right, buried rocks heat up while exhumed rocks cool off. So I found that she said that. I just found it interesting as a like a heat exchange kind of thing where like a system, like generally speaking, heat from down below like flows upward, right? Hello, I'm like a little bit of heat. Hello. But sometimes a lot of bit of heat needs to like flow upward, and it does so by like a hot object, like a Pluton, just being like bloop, bringing the heat up, and then the heat is up, but radiated outward and out by this like system that just brought the heat up in a way. So like buried rocks become heated. At least that's how she put it, and maybe how we think of it. Probably how we think of it, but I would say rocks that experience currents become heated. Like if there's no currents present, there has to be currents present. Just even within like a magma, like there's just heat flowing within it, so there's currents present. But if there's not currents present, then it just will cool off. But besides the point. Generally speaking, the concept though, buried rocks heat up, exhumed rocks cool off. Solid. Rate of production of helium. Pardon me for being an ass. I know. Anyways, I'm an ass. Just pardon me. Thanks. Helium diffusion temperature sensitive. Okay. Closure temp. Helium trapped in the mineral. So zircon. I'm not even sure what this is. Okay, thorium. I was thinking maybe thorium. Cool. Okay, so using uranium, thorium, decay related things or something to do. I know it's ridiculous that I don't know exactly. I'm just like trying to get information that pertains to what I'm looking for specifically. So like sometimes I'm just like, I don't know. I'm just looking for like this information and I got it. Take, put here, place, move on. Zircon closure temperature 140 to 220 degrees Celsius is useful because I'm like messing up. I forgot. It's pretty complex. So to like casually summarize is admittedly a little difficult. This was a big part of it, but I'm getting past. Like good slides. Like here we go. This is a good one. So like the ranges. I believe this is the ranges where yeah, okay, there we go. Let me find the notes on this. Interval. Okay. Helium atoms moving in the crystal and then they hit this zone, a damaged region that's caused by the decay of uranium to thorium. I'm not sure exactly. This decay causes damage within the like polygonal crystal, breaks a boundary, and then as a result, the helium atoms moving in the crystal have a higher probability and chance that they enter a region that they can like leave the crystal, and then they do. So the crystal much faster, they leave the crystal much faster than they would otherwise. So when the crystal is in high temperatures, the crystal will heal the decay damage so that it doesn't have like a gap for the helium to exit. But if it doesn't heal the decay damage, I'm just realizing this is literally like like an atom radiating, an atom decaying. Like the way the helium escapes is like how the whole system of this crystal, which is also like an atom, which has its boundaries, is like temperature dependent radioactively decaying helium atoms that maybe aren't helium relative because it's a huge crystal grain probably, but like maybe it's something else that's closely tying the things, like processes together that I'm not thinking of now. Pardon me as I just spitball that, and I think it does have some interesting potential just off the top of my head, but I know people are offended by possibility. So, I love you. Same. Okay. Um, so that high temperature, though, the crystal will heal when the decay damage occurs so that it does not accumulate. So it takes like repetitive decays to really assist the process into breaking through, and then like the hydrogen or helium getting out so that it can be measurably at different amounts of helium that indicate the actual the age, I guess, or the temperature, probably. At low temperature, the crystals are damaged more and more with each decay. Greater than 240 degrees Celsius, at least for these crystals, heal the damage so that then the helium cannot escape. So above a certain temperature, basically, it's no longer radioactively decaying because it's more stable in a higher pressure environment. It's probably something of that nature going on. I've talked about that with regard to radioactive decay, like in my book, like a while ago, that kind of concept, where there's basically what's happening is an atom has a pressure that it radiates outward, an inflow and an outflow, where the pressure outflow and then the inflow have a balance, and if it's equal, then it means there's a neutral system, which maybe actually was really useful for determining which systems are neutrons, which are protons, because if it's basically overwhelming the environment with its outflowing current, then it has a positive pressure, like a proton has an outflowing current, electrical current, and then a electron is basically being overwhelmed, which is maybe apt. I've never seen on this thing these currents. I've never seen them quite. Oh, this might be a good time to check out what's going on here. That storm front. I saw this. Maybe I can find it. It made me. I was like, whoa. It's like a supernova. It's a couple days ago. It's like a wave from a nova. It made me think like some particle decayed that had like pressure on some sides. So like there's high pressures around, and some like nucleus system decayed and just sent like a wave of a burst of cold air. Like the way it looked. If I can find it. I'm pretty sure it's really obviously like the storm. I'm not looking at the names at all. What are we at, Wednesday? Okay, it could still be here. Scheiße. I don't want to search. I don't. One more page. Almost. Could this be it? Here we go. This has got to be it. None of these. Oh my. Where is it? Maybe it's earlier than I found one, so. Let's go a few days back. It looked like that one, I'm pretty sure. Feel free. Oh, maybe I found it. That looks more like it. Like a nucleus burst, and then there was a container that held the energy that it poured out of this way, and just sent this blast of cold air. Merry Christmas. Thanks, Santa. Sorry, I'm down here. I'm alright. Sorry, guys. Bomb cyclone. Okay. That's still not it. There's a video that even showed it, like. But that's probably good enough to only go like 2 more pages, and then I'll stop, right? Okay, it can't be. I mean, it's so many articles, though it could be. Oh. I don't think that's it, though. Okay, I'm sorry. I probably passed it. The one we just looked at was pretty solid. I should have stopped there. Okay. So then she said she was talking a lot about it's called Kiev. I googled it here. This name. Kiev quartzite. Some type of quartzites. That maybe is better just to look at. If I can find it. She shows it kind of looks like a Lyson gang ring. The portion that I can see, it looks like Lyson gang to me. I don't know what to make of it. It makes me think of this kind of structure. Garden of the Gods. Not sure if it's related, and I mean, it's definitely related in terms of the current flows related to how this formed, but I'm not sure if, like, it's considered a Lyson gang even. It looks like it could be. I don't know. Okay. But interestingly, these things were forcefully emplaced up to 1 to 2 kilometers into the crystalline basement. These structures, kind of like nodes, forcefully emplaced into the crystalline basement. And they require sand remobilization, so it means sand was sitting on the basement rocks when it formed. 0.5 to 1 kilometer max emplacement into the basement rock. So I'm thinking of it as almost like a electron exchanged like an outer shell electron exchanged between plutons that, well, not between plutons per se, but the pluton absorbing a outer shell electron from an adjacent system that is basically manifesting this way. Something of that nature, maybe. Host rocks were in the near surface and cold when the Tava formed. Host rocks meaning meaning the basement rock that they're in. Okay. These are found more so in the Front Range. Over here, which is maybe where bonds are forming between adjacent units. Like if there's fracturing, then it's breaking the units into separate units, and so maybe it's more likely for there to be like a bond in encouraging things that like encourage current flows to connect adjacent units of the earth to one another across scales and do things that are not really part of our nomenclature but are happening because it's cool. And isn't reality awesome? All of these Tava Kiev quartzites have high probability of correlations to sedimentary rocks derived from the Grenville origin and deposited in, let's look at where that is. Grenville orogeny. So the Appalachian region. Ew. Ew. Oh. So it was like tearing up. Oh. These are before the Earth expansions process started to occur, when birds were still chirping and ancient Dwarka was not attacked yet by a vortex weapon. Not that birds are not chirping now, but there was a time when things were a little hectic. And, I'm sorry if I'm wrong. You gotta see all the reason why you should still listen to me when I say things like that. At least someone should. The community at large should. Maybe not you individually, but like the words I'm saying should be accounted for by the community at large. For science. But these are deposited in western Laurentia from over here between 800 and 680 million. Not sure what to make of that. It may be like the very first beginnings of the currents just kind of start to bring some of this material over. It goes over to the other boundary that's kind of forming or pre-existed to a degree, because there's probably still like support structures underneath that generally separate enough where it's still separate. Just relatively, it was all generally uniform comparatively, where like sequences break apart and then there's noticeable bonds. So, I'm sorry if I'm a little hard to follow. The uranium, thorium, helium analysis of veins that mutually cross-cut the Tava-Kiev dikes in the Williams Fork Range document injection in the range of 676 plus or minus 26 million years. Basement rock near the surface, no more than 2 kilometers away from the top for when this Tavakia Formation was forming around 700 to 650 million years ago. So it's really in that range where it could be before the Earth. Like it could be unrelated to the attack on ancient Dwarka, but it may be like the very beginnings of currents flowing. It's a little hard to say exactly because it's about at that boundary zone. It seems like it's tied to it. That's why I'm like kind of leaning towards it's caused by the vortex weapon, honestly. But open to otherwise. Although, honestly, just the fact that it's arriving in the same place that the currents are arriving means it's almost assuredly tied to the currents because, I mean, like, the currents go everywhere, but certain places they especially propagate, like, preferentially, and it's going to the mountains in the region, which to me is because it's flowing with the currents of the expanding Earth. And otherwise, like, it wouldn't have gone to that region. It would have been over here, probably. That's where it was. That's where it formed. That's why it was there, because that's where the currents took it when it formed. But then other currents brought it over here later. So I would say that this is probably really the beginning of the Earth expansion process. It goes all the way back to then. Maybe even to 900. I don't know what to make of it. I mean, not probably not 900, but just that this has that range. It doesn't mean it could be that 900 is when the Earth stabilized and then or it began to stabilize and then approaching a certain time frame it really was stable and then radioactive decay slowed down and then we like existed here for a period of time as an advanced civilization that gave birth to our civilization. And then the Earth was attacked by a vortex weapon somewhere around when this broke apart. The next deposition was on the Great Unconformity around 500 million years. Ancestral Rockies Unconformity 320 to 280 million years. So there's multiple unconformities that, and then that one is a 40 million year one. It just shows that it's times when currents flows and currents were flowing to that location specifically and times when they were not. And right now there's really no currents flowing, like relatively speaking, in a way that's detectable. So it looks like it's kind of just stopped, relatively speaking. Okay, let's move on. Average appetite helium age 58 plus or minus 4 million years. So, like, there's this, as she points out several times in here, there are rocks that within the same rock has a range of grains of zircon with the uranium thorium decay, helium contained all the way back, spanning to basically to what it really is probably like this one's probably the beginnings of the Earth expansion process when currents just kind of passed through the region. And then they filled the region, like there was essentially a phase change where like the currents passed, filled it, but then they moved on, like, because there was stuff underlying the region then that was blocking the currents from further flowing, and so then they came back again after they, like, experienced pressure elsewhere, and then it looks like they even start to show up almost like in the time frame building into the Siberian traps and the supervolcanoes in or in Australia and probably other things in this region of time. And then like especially supernova time frame from around like 120 to around 55, and then it really dies off, like its cooling off phase begins like right after rapid expansion begins, because essentially the earth is expanding from the oceans, and so these currents really like stop practically, relatively speaking, so then they can just kind of cool from maybe from the wind even of them moving. Like I'm sure it was very energetic wind currents on the planet at the time. Okay, okay, here we go. Late Neoproterozoic thermal event. This is... I think it's here. I'm not sure. Thermal... Somewhere she starts going into thermal events. And after the... So after the deposition of these Tava-Kiev formations and before Cambrian deposition onto the Great Unconformity, which is basically the level that ancient society was living on at the time, was around the Great Unconformity, I believe. So before deposition on that level, but after the Tava-Kiev formations, there was a thermal event from 650 to, actually, now I know where it is. 650 to 500, although then she puts it at different ranges dependent on the model and interpretation. So like some people will say the Tava constraints are much larger, which then means the heat induction is much larger, range, etc., things of that nature. But I generally would say this one makes sense, although it's maybe more so one of these if rather than this way, just from my understanding without any, it's almost like, I know better. I think it's gotta be that way kind of thing without actually looking at the data that closely. That certainly is a thing that happens. And I ain't exempt from it, but neither is anyone in science, so, or in life probably. But then it says, she said, long lived, at least 16 years of greater than 220 degrees Celsius in the rocks. Not hot enough to go above a point where it like resets the clocks, but hot enough to just keep it heated for a long period of at least 16 million years, and with an average time of 78 plus or minus 29 million years. Sufficient heat present to reset the zircon helium, but not to perturb the argon chronometers, something. So basically, some of the clocks are reset at certain temperatures, so they're able to determine things of that nature. that it was basically at a temperature range. It was above the temperature to reset the zircon helium clock, but below the temperature to reset the argon clock. Whatever exactly the clocks are, pardon me, but in that temperature range for a long time. 16 million years. Minimum up to 100 million on average. Dude, why? Like, think about that. Well, this is a different Earthland. Oh, I mean, if you say so. Are you sure it wasn't just like rapidly cooling, but like lots of heat for a time? Essentially, a lot of heat for a period of time that was a supernova of a particle on the planet. Oh my god, people, like, what the? How does anyone even come to these ideas? I'm just baffled how anyone could even have these ideas. They don't even make sense. Like, how could someone get to that? Only one way to find out, huh? Okay. Likely controlled by spatial. Okay, here we go. Range interior does not show heating document. All right, heating erased. Documentation. Range interior likely controlled by spatial variables resetting during latest Cretaceous time. Like right at the supernova, there's enough heat at the latest Cretaceous time to make it so that only the ones further away don't have the argon clock reset, but the ones closer do. I guess that's the clock that gets reset. Like, so over here, they're not reset, I guess. And over here, I'm not sure how far the front range versus interior is. It may just be like miles, couple miles. I don't know what scale we're looking at here, if it's all within this region. But essentially, there's a region that did not experience enough heat, and a region that did. At the latest Cretaceous time, specifically, and just generally, prolonged heating of the rocks is a phenomenon in this region, which really just again gives credence to that there's something of a swirling nature like this, of just a magma of current nearby, like right here, but also right here and up this way. This is around Florida, around Texas, around Baja, California, BC. This may be around, like, Yellowstone, I don't know. Essentially the current going this way, but then with some upward motion. Let's check out the animation I made. Pretty sure I saved it, I hope so. Okay, good. I'm not sure what to make of this region, really. It certainly needs adjusted for a smaller globe to make actual sense to use this. So it's almost it's a little tricky. Like this might actually be all the way up here at that point, and this region more so here. Let's envision it that way, where this is like cupping this region, making it a full-blown circle, like this circle here would mean these things just are generally back this way, where it's going up into it. It would basically be going this way, this way, this way, and then up into it around this way. Like while going straight on a smaller rounded globe. I know it's a smaller radius globe, and with a single landmass, basically. Where then it runs into resistance at that time of this region. I don't know, does this have possible correlation over here? Like, not necessarily Hawaii itself, but the surrounding undercurrents that were there. I mean, if this is kind of here, then that really does make it possible for Hawaii to have been at the Bighorn Forest as a sphere beneath it. Or maybe at Yellowstone. Up here? I don't know. Something is up with this Hawaii. I just don't know how it got there. It's so... like, to not have this model irrefutably worked out is frustrating because of how ridiculous it comes across as. Even though I'm like, dudes, I ain't making this shit up. I'm just looking at the data. Maybe some of it's wrong, but like some of it you gotta acknowledge. Sooner or later, it's gotta be acknowledged. A normal fall, basement rocks, breakaway. Okay, so front range, basement rocks break away at the rifting of Rodinia. This is from this video still. At the rifting of Rodinia, the basement rocks break away. This is I believe it's the prevailing theory interpretation of what's going on, and maybe based on their research specifically. I'm not sure how many people involved in this research she's presenting. But basement rocks break away at the rifting of Rodinia. So when this breaks apart, like fragments happen, and like the breaking isn't clean. It has like thrusts, or faults, not thrusts. Pardon me. Faults. And up to hundreds of kilometers long. At least I think that's based. She had a reference and said a normal fault with 3 to 9 kilometers of throw has tens to hundreds of kilometers in length. With a reference, so I'm assuming that there's like awareness that the normal faults in the region are 3 to 9 kilometers of throw. And then it's hard to determine the fault length, and so they are potentially 10s to hundreds of kilometers in length. These things here, speculative rift faults. So yeah, I guess it is speculative rift faults. Oh, interesting. So we don't really even see faults to the point where we're just speculating there's faults. Interesting. It probably is though, just from the sheer amount of energy that it's just like a different dimension of faulting in a way. But like it still allows for upwelling through it. Kind of like the helium versus the argon, like a fault. Maybe exactly that, exactly that, where like it can heal. These things can heal too by just like currents flowing into them, bringing material and just filling. Pressure, the current with pressure, like it needs pressure to compact it in and then fill it in. And boop. Okay. Yeah. So essentially, she also said that this range, therefore, has its origins in the Neoproterozoic when the rifting began. So really, it connects it to the expanding Earth process because this rifting was 100% caused by the currents colliding in the region when the Earth was expanding, and so 100% these faults in the region, etc., are traceable back to the breakup of the Neoproterozoic Rodinia. Where essentially, I believe it just starts to open, like the current's coming in down this way, it flows this way, and down this way. And ends up going mostly this way though, and opening a gap here and pushing this over to the side, rotating it, kind of like this. Just rotating Australia in the current, and then this is kind of like Papua New Guinea, where it's like a chunk on the side. I don't know, some bonds breaking, like the way that shapes itself. There's a lot of things going on here. I'm not sure if that was the best reference to say Papua New Guinea, but just the shape it was taking initially and the way it's got this like, it's like at a boundary where the currents are flowing. And so they mark the easternmost extent of the rifting into Laurentia. So like when this energy propagated and started to produce a physical supernova radioactive decay of a system underneath Australia at all, that's its influence into the surface crust of this region that was basically here adjacent to Australia. To a degree, I'm not sure if this is exact. I'm just, based on this, I would say that probably this is really accurate, and maybe Papua New Guinea was up here with the Philippines here, and Sulawesi and thingamajig, North Maluku Islands here, Papua New Guinea up there, and connect. It just turned like that, like this, and reconnected. Like ended up bonding as it turned and moved down. So maybe it like bonded and brought and moved down, creating portions of the region that it matches here. I'm not sure what to make of it, honestly. Like, this does not match what I've interpreted in the past, the Papua New Guinea aspect of it. Although maybe it wasn't even attached to it. I'm not sure what to make of it. I mean, certainly Papua New Guinea and so on can't be attached to a crust that does not yet exist, so there's that aspect of it going on. I'm just not sure what to make of it. Maybe as this turns, it does do exactly that, where it gives birth to little offsprings. So like this segment that is of the rotating Australia plus Papua New Guinea and so on gives birth to a little chunk that like over time begins to form in like a relationship to that segment in a way where they end up like doing this. Maybe it would be useful to just show like this kind of like this. This is not happenstance where there are basins with similarities of the sheer quantity and extent that I draw here. Like they were adjacent. This I can say with a confidence. They were adjacent. So, if this formed accreted, I'm not sure. I'm just not sure what to make of it with regard to. I mean, it's so far back in time that it does give a window when the rotation could have occurred, because I know Expanding Earth Models plays Papua New Guinea further up here, and so maybe I've inadvertently recognized an intermediary stage, really, when they broke away, where they were at the end, rather than how it was the whole time Australia was there. I don't know. Okay, this is long enough. See y'all later.